covering 4-3, congruent triangles. Remember to take notes and complete the check it out problems.
We have two learning targets today. The first one, I can use properties of congruent triangles, and I can prove triangles congruent by using the definition of congruence.
A few vocabulary words that we want to take note of: corresponding angles, corresponding sides, and congruent polygons. We'll see those definitions later, but you'll want to get them into your notes.
Here's a nice diagram, the properties of congruent polygons. I suggest you copy this into your notes. And remember, looking at a picture, we only can tell what's congruent by what the markings on here. So again, the tick marks here means these two, I'm sorry, let's do that one differently. I mean, this side's congruent to this side, and 3 tick marks here will be congruent to there, and then we have AB is congruent to ED, and the angle markings are congruent. And it's important how you're naming them. Corresponding angles and sides must match up. We'll talk more about that in this lesson. And also your polygons here too. So copy this into your notes and we'll talk about this.
So to name a polygon, you write down the vertices in consecutive order. So ABC is an example of naming a polygon. So if you have a polygon PQRS, and this is different from a plane, which extends forever, so that's why a plane has 3 letters. Polygon, you put all the vertices down. So polygon PQRS could be named as QRSP or SRQP, but not PRQS because these 2 letters are out of order. So you want to keep the letters in order. In a congruent statement, the order of the vertices indicates the corresponding part. So a little example, if I have triangle ABC congruent to triangle DEF, so this means that the vertex A corresponds to vertex D here. So those 2 angles are congruent. Vertex B corresponds to vertex E. So those 2 angles are congruent, and vertex C is congruent or corresponds to F. So be careful when you're naming corresponding or congruent polygons and triangles. The other helpful hint, 2 vertices that are endpoints of a side are called consecutive vertices. So in ABC, you can see that we have AB next to each other here, and BC are next to each other, and they are next to each other in the picture here as well.
Okay, so let's name, we're given triangle PQR is congruent to triangle STW. We want to identify all pairs of corresponding congruent parts. Okay, so when we're given these 2 triangles, highly suggest you draw the pictures. Triangle PQR, so draw a triangle PQR. Those are 3 vertices. And then we have triangle STW. So those are our 2 triangles, and we're told that they're congruent. So now we have segment PQ, and you can, so this segment here is congruent to segment ST. Segment PQ is congruent.
QR.
Thank you, QR. Oh,
Mark the
QR
parts.
is congruent to TW. And then we have PR is congruent to SW. And notice the tick marks increase, showing that which sides are congruent, the corresponding sides. Now for angle measures, we have angle P is congruent to angle S, angle P, angle S, angle Q is congruent to angle R, or angle T, I don't know where that R came from, and angle R is congruent to angle W. So again, when you write a statement, this is helpful hint down here, you write a statement such as angle ABC congruent to DEF, you're also stating which parts are congruent, so order does matter. Whatever you can start with this left-hand side, then you need to make sure your right-hand parts match up to what you started with on the left-hand side.
All right, so you have polygon LMNP NP is congruent to polygon EFGH. So you should identify the pairs of corresponding congruent parts. So you would list all the congruent sides and congruent angles of those two polygons.
Yay. Okay, so now we're looking at using our corresponding parts of our congruent triangles. So in this example, we're given triangle ABCD. So we have triangle ABC is congruent to triangle DBC. Got too many letters in there. DBC. So those two triangles are congruent. And let's mark which parts are corresponding. So we have angle A. This has to be congruent to D, angle D. And we have angle B. It has to be congruent. We have this angle B in this triangle here is going to be congruent to that angle B in that triangle. And then angle C is the angle in here. And that happens to be a right angle. So now let's find the value of x. Okay, so find the value of x. So we know that 2x minus 16 has to equal 90 because these two angles here are corresponding, so they're congruent. Solving for x, we get x equals 53. Now we want to find the measure of angle DBC, this angle measure in here. We know that angle D is 49.3 because it's the same as measure of angle A. So we can take 90, because these two angles here must equal 90, they're complementary, minus measure of angle D, and we get measure of angle DBC to be 40.7 degrees.
All right, so for this check it out, you're also going to find the value of x and also find the measure of angle DFE. Good luck.
Okay, here's a proof, proving triangles are congruent. So we're given that triangle, or we're given that angle YWX. Let's mark that angle over here. Angle YWX and YWZ are right angles, so we're marked here. We know that's the right angle there also. And that YW bisects. Bisects again means divides into two equal parts. The segment, or the angle, XYZ, which gives these two angles are congruent. And that W is the midpoint of segment XZ. Midpoint means that those two segments are going to be equal measure. And they were also told, there's a lot of stuff here, that segment XY is congruent to segment YZ. So we're starting out with our proof. We have what we're given, that the two angles are right angles. And we've got those marked in our picture. And now we can make the statement that those two angles are congruent because all right angles are congruent.
Makes sense.
Yeah. And then we know that, there should be a segment bar over here. Segment YW bisects the angle here, and that was a given. So we're using our givens and feeding into the next one. Now, the next statement is the two angles are congruent, angle XYW. Up here we mark those two angles are congruent because it was bisected. Now we have our midpoint that was given. And the next statement, definition of midpoint. We know that these two segments here have to be congruent. Definition of midpoint. Then, our segment in here, going down the middle, segment YW, is congruent to itself, reflexive property of congruence. And then we have the angle X is congruent to angle Z. Because two angles of one triangle are congruent to two angles of another triangle, the third pair of angles are congruent. What's that theorem called?
That's the third angle theorem.
Yeah, so you could have a third angle theorem. The same thing. And now we're down to the segments XY is congruent to YZ. And that was also a given. So looking at our picture, we have, let's draw in the congruence lines here. That was congruent to itself. So we have these angles were congruent. So now we have all corresponding angles are congruent and the corresponding sides are congruent. So our last statement, or a reason, It's going to be definition of congruent triangles. That's a long proof.
All right, it's your turn. So given that AD bisects BE, so AD cuts BE in half, and BE bisects AD, so this one cuts AD in half, and you're also given that AB is congruent to DE, so, and the tick marks are already up there for you. And angle A is congruent to angle D. Those congruence marks are up there. You need to prove that triangle ABC is congruent to triangle DEC.
Keep in mind you got vertical angles in there. That might come in handy.
I bet it will.
Yeah, bisect, big midpoint.
Okay, good luck.
Okay, so to sum this up, we're looking at congruent triangles today. For triangles to be congruent, you have to be able to have all the corresponding angles and sides of the polygon be congruent. So you need to be able to name the corresponding angles and sides and then show that they're congruent. To prove the triangles are congruent, again, you have 3 pairs of corresponding angles and you have their corresponding sides have to be congruent. Hence, that's why we're doing congruent triangles today.
And we're going to get to shortcuts on this in the next few sections, so it's not going to be nearly as complicated to prove that triangles are congruent very soon.
A few more theorems coming up.